Hey guys, in our last lesson we worked on factoring polynomial equations. So for this one we are working on solving those polynomial equations. So same type of process, we just need to take it one step further. So considering factor methods, we look for common monomials. So the greatest common factor, things that we can pull out and divide out that all of them have in common. Then we look at special patterns. We see if we can factor by grouping, and then we try to split the middle. So those are our 4 steps as we're considering factoring. So here we have 4x to the 6th, 4y to the 6th, and we're subtracting. So that looks like a special pattern to me, but it looks a little different than we've seen before. First off, I see I can take a 4 out. So then I have x to the 6th and y to the 6th. And what I want to show you is you could write this one of 2 ways. You could write this as x to the 3rd to the 2nd power minus y to the 3rd to the 2nd power. Or you could write it as x squared to the 3rd power, y squared to the 3rd power. I'm going to write this as x to the 3rd to the 2nd power minus y to the 3rd to the 2nd power. So now it looks like a difference of 2 squares. So now if I write that, I still have my 4 out front, and then I have x cubed plus y cubed and x cubed minus y cubed. So now that we have x cubed plus y cubed and x cubed minus y cubed, we have a sum of 2 cubes and we have a difference of 2 cubes, which means we can do some more factoring. So I'm going to put this 4 out front. I know that I have x and I have y, and then I have x squared, and then I have xy, and then I have y squared. Remember our special pattern there? When we're thinking soap. Same sign, opposite sign, always positive. And then for my difference of 2 cubes, again I have x, then I have y, then I have x squared, then I have xy, and then I have y squared. Same sign, different signs, always positive. There's my simplified form. I know it doesn't look more simplified, but it is the factored form of 4x to the 6th minus 4y to the 6th. That's how we can simplify it out. All right, looking at this next one. When I'm factoring here, I have 4x to the 4th minus 5x squared minus 9. We're going to treat this a lot like if it were 4x squared minus 5x minus 9. So we need 2 numbers that multiply to a negative 36 and add up to a negative 5. So I'm thinking 9 and 4, and I need a negative 9 there. So now I have 4x to the 4th minus 9x squared plus 4x squared minus 9. So now I'm going to take out what I can. So I can take out an x squared in this first one, and I'm left with 4x squared minus 9. And then in the second one, I can't really take anything out, so I'm going to take out a 1, and I'm left with 4x squared minus 9. So then I have x squared plus 1, and I have 4x squared minus 9. That x squared plus 1, if we're okay factoring over non-reals, that's a sum of 2 squares, so that's x plus 1i and x minus 1i. And we have a difference of 2 squares here, so that's 2x plus 3 and 2x minus 3. So there's our final factored answer from our original expression there. So now, today we're taking it one step further. We're going to set that equation equal to 0. So we may need to move some things over. Then we're going to factor. Then we're going to set each factor equal to 0, and then we're going to solve. So let's do a little practice here. So if I want to solve 2y to the 5th minus 18y, the first thing I'm going to do is take out this 2y that I see they both have in common. So then I have y to the 4th minus 9 still equal to 0. So now this y to the 4th minus 9 looks to me like a difference of 2 squares. So I have 2y and I have y squared plus 3 and I have y squared minus 3, not 9, y squared minus 3 is equal to 0. So then from there, you can go ahead and factor that out. That's going to give you a radical in there since the 3's aren't perfect squares. You could just set each piece equal to 0. So 2y equals 0, y squared plus 3 equals 0, and y squared minus 3 equals 0. So 2y equals 0, I can divide both sides by 2, I get y equals 0. That's one answer. I can move over this 3, so I get y squared equals negative 3. If I take the square root of both sides, I get y is equal to plus or minus. That negative tells me I'm going to have an I out front, and I have a radical 3. So then, on this one, I can add 3 to both sides, and I get y squared equals 3. I do the square root of both sides, and I get y equals plus or minus radical 3. So in total, I have y equals 0, y equals positive I root of 3, y equals negative I root of 3, y equals positive radical 3, and y equals negative radical 3. So I have 5 different answers here on our one factored problem. All right, on this next one, I have 3x to the 4th plus 15x squared minus 72 equals 0. This one looks to me like first we need to see if we can take anything out. And it looks like they're all divisible by 3. So I can divide all of them by 3 and put that 3 out front. So then I have x to the 4th plus 5x squared. And then I have minus 24 is equal to 0. So I need something that multiplies to negative 24 and adds to 5. So I have x to the 4th. That would be a positive 8 and a negative 3. That adds up to 5. That multiplies to negative 24. So then I'll see what I can take out of the first two. So I have an x, oh sorry, these should be x squared since they're 5x squared. So I have an x squared that I can take out then. And I'm left with x squared plus 8. And then on this set, I have a minus 3 I can take out, and I'm left with x squared plus 8. That's equal to 0. So then I still have this 3 out front, and I have x squared minus 3, and I have x squared plus 8. All of that's equal to 0. So we can set each of these pieces equal to 0. So if I set 3 equal to 0, that's never going to be a true statement. So that's just kind of irrelevant at this point. We need to bring it down with us, but it's not going to become a solution. And I have x squared minus 3 equals 0. And I have x squared plus 8 equals 0. So if I add 3 to both sides, I get x squared equals 3. Take the square root. So x equals plus or minus radical 3. And then if I subtract 8 from both sides, I get x squared equals negative 8. Square root on both sides. Now, negative 8 we can simplify down into plus or minus 2 radical 2. But I also have that negative to deal with, so that's an I coming out front. So 2I radical 2. And then we also had plus or minus radical 3. So in this case, we had 4 different answers as our solutions. Then I have 2x to the 5th minus 512x. So the first thing I notice is both of those are even, so I can at least take out a 2 there, and since 2 is the biggest number in this first one, that's all I can take out, and I can take an x out of each of them. So then I have x to the 4, and that's minus 256, and set that equal to 0. So now that looks to me like a difference of 2 squares, so I'm going to bring that 2x out front, and I have x squared plus, and the square root of 256 is, hang on just a second, 16, and then I have x squared minus 16 is equal to 0. So now you could go ahead and factor this out even further, but from here we could say 2x equals 0, x squared plus 16 equals 0, x squared minus 16 equals 0. So then 2x equals 0, x equals 0. X squared plus 16, so that's x squared equals negative 16, squared on both sides. So x equals plus or minus 4i. So 2 answers there. And then if I get x squared equals 16, square root of both sides, x equals plus or minus 4. So 2 more answers there. So in total we had 5 answers here. All right, so that's all I have to cover for solving equations today. We'll do more of this practice in class. If you have questions, feel free to come in and see me. Have a great night.